Okay, so this is our lesson 3 on the basic concept of functions. And basically, part B is where we're talking about evaluating functions. So this is lesson 3 of evaluating functions. Make sure you go back and you understand lessons 1 and 2 as well. All right, but basically, number 3 is going to involve these kinds of ideas that you're about to see. For number 1, let's kind of review something we've had already in one of the previous lessons. Suppose that g of x is equal to 2x minus 5. And you want to find, let's say, g of 6. Okay? Well, g of 6, remember, is wherever you see the variable x, you're going to substitute 6. So that's how you'd find g of 6. So you'd say 2 times 6 minus 5. So that's 2 times, remember, use your order of operations. You multiply before you subtract. 12 minus 5, which gives you 7. So then you would say g of 6 would equal 7. All right? But let's suppose in part B, you want to find 3 times g of 6. Suppose it was that. All right, 3 times g of 6. Well, keep in mind that we've already found g of 6. So we found g of 6 to be 7, right? So this becomes 3 times 7, which is 21. So you would say 3 times g of 6 will equal 21. All right? Now suppose we had C. Suppose in C you want to find negative 2 times g of 5. Negative 2, remember how to read this. This reads negative 2 times g of 5. So what you got to do first is find g of 5. So let's go ahead and find g of 5. So g of 5, and remember g of x was this. I'm going to rewrite it. That was your function. So where we see the variable x, you're going to substitute 5. So this becomes 2 times 5 minus 5. So that's 10 minus 5, which is 5. So that's g of 5. So this right here becomes negative 2 times 5, which is negative 10. So therefore, you're going to say negative 2 times g of 5 equals blank, negative 10. Okay? All right, let's look at number 2. Number 2, let's suppose we had this for number 2. Now this time, you see how in this case you were given an equation for your function? You're given an expression like this, 2x minus 5. So you have this equation, but it is written in function notation. Number 2, let's suppose we had a set of ordered pairs instead. So let's suppose we had this for number 2. We had f is equal to, and then we have a set of ordered pairs, 4, 7, negative 3, 2, 5, negative 1, 6, 2. Okay? So we had this finite set, and so this is my function f. Now remember the x coordinates, so your first coordinates. So x, this is your x, so x will be 4, negative 3, 5, and 6, right? And then the y coordinates will be 7, 2, negative 1, and 2. So in part A, suppose you want to find f of 5. Now remember, in one of our discussions in one of the lessons, remember f of 5 means, remember what that means. That means what is the y coordinate when x is 5. Remember that? That was one of the things we had. I think it was in lesson 1. So basically, you're gonna find, well, which one has x to be 5? So this is not it because that's 4. This is not it because that's negative 3. Hey, this is it. That's when x is 5. And so the question is, what's the y value? Well, the y value is negative 1. So that's what you put. So you'd say f of 5 equals negative 1. Okay? Part B, let's say you want to find f of 6. Same idea, right? So this means what is the y value when x is 6? So basically you're going to find out which one says x is 6. That's this one. So what's that y value? The answer is 2. So f of 6 equal 2. C, suppose you want to find f of 5 plus f of 4. F of 5 plus f of 4. Well, what you got to do here is you got to do two separate things. Okay, you got to find f of 5 first, then you find f of 4, and then you add them up. That's what that says. So again, let's do f of 5. So f of 5, remember, it means, and remember, this is your function, well, your function's up here. So f of 5 means what's the y value when x is 5? So if x is 5, my y value is negative 1. So that goes here. So f of 5 is negative 1 plus f of 4, so that means what's the y value when x is 4? So when x is 4, my y value is 7. And so therefore, your answer is going to be -1 plus 7, which is 6. So you're going to say f of 5 plus f of 4 is equal to 6. Okay? All right, so that was that one. Let's look at number 2. Let's suppose this was number 2. So number 2, we have this set of ordered pairs. Number 2, let's suppose this time our function is called g, and we have 0, 4, -2, 3, 7, 2, -3, 4, and let's say 8, 7. Okay, and you want to find each of the following. So let's suppose in part A, you want to find g of 0. All right, well, remember what that means. That means what's the y value when x is 0? So x is 0, my y value is 4. So g of 0 equals 4. There's your answer. B, let's suppose you want to find g of 8. Same thing, right? So what's the y value when x is 8? So you find out which one says x is 8. Well, that's this one. My y value is 7. So g of 8 is equal to 7. C, you want to find g of 7. Okay, well, same thing. What's the y value when x is 7? So when x is 7, that's this right here. My y value is 2. So g of 7 is equal to 2. All right, not that difficult, pretty easy, right? Let's look at D. Suppose in D you want to find 3 times g of -2. Remember how that reads. You gotta understand that this means 3 times g of -2. So we got to go off and we got to figure out, well, what is g of -2? That's what I got to do first. And whatever that is, I'm going to multiply by 3. Well, g of -2 means what's the y value when x is -2? So here's the one that says x is -2. My y value is 3. So g of -2 is 3. So this means that this right here becomes 3 times 3, which is 9. Okay? And let's suppose in part E you want to find, let's say, 2 times g of 0 minus 5 times g of, let's say, 7. All right, so let's do actually negative, that's fine, 7. All right, so 2 times g of 0 minus 5 times g of 7. So again, we got to find g of 0, we have to find g of 7. And then we're going to manipulate what we have. So g of 0, y'all agree? G of 0 means what's the y value when x is 0? So when x is 0, my y value is 4. So this is 4. So this becomes 2 times 4 minus 5 times and whatever g of 7 is. Well, g of 7, remember, what's the y value when x is 7? So I find x is 7, which is this one. My y value is 2. So this becomes 5 times 2. And then using the order of operations, I'm going to multiply, and then subtract. I get 8 minus 10, which is -2. So therefore, your answer, you're going to say 2 times g of 0 minus 5 times g of 7 is equal to -2. Okay? All right, so that was number 2. Let's look at number 3. All right, number 3, it's written like this, number 3. So you're given this mapping. So it looks like this. And so here's your function. So this function takes 0 and maps it to 3. This function takes 2 and maps it to -1. This function takes 3 and maps it to 4. This function takes -2 and maps it to 5. Okay? And in part A, let's suppose you want to find a f of 2. So remember, see how it goes from here to here? So let's think of this as your x and this is your y. Is that clear? All right. So what's the y value when x is 2? Well, if x is 2, my y value is what? -1. So f of 2 equals -1. It's the same thing. It's the same thing you had with when you did the set of ordered pairs, except it's written in terms of a correspondence or a mapping. B, you want to find f of 3. So again, what's the y value when x is 3? So if x is 3, my y value is 4. So f of 3 is equal to 4. C, suppose you want to find f of 2 plus 3 times f of negative 2. All right, so f of 2 plus 3 times f of negative 2. So let's first of all find f of 2. So f of 2 means what's the y value when x is 2? So when x is 2, my y value is negative 1. So this becomes negative 1, right? Plus 3 times, and then we got to figure out what f of negative 2 is. So f of negative 2 means what's the y value when x is negative 2? So when x is negative 2, my y value is 5. So it becomes 3 times 5. And so I get negative 1 plus 15, right? 3 times 5 is 15, which gives us 14. So therefore, the answer, you're going to say f of 2 plus 3 f of negative 2 will equal 14. All right. And then let's do DE. That's C, so let's do D. So D, let's suppose we had negative 5 times f of 3. Negative 5 times f of 3. So remember, f of 3, we got to think about what f of 3 means. F of 3 means what's the y value when x is 3? So when x is 3, my y value is 4. So it becomes negative 5 times 4, which is negative 20. So your answer, you're going to say negative 5 times f of 3 is equal to negative 20. All right, so that was number 3. Let's look at number 4. Number 4, we have this. So we have this correspondence, kind of like the last one we had, except let's call this G. So G takes 3 and maps it to negative 2. G takes 6 and maps it to, oops, I didn't mean to do that. All right, let me redo this. I want to do it a little bit different. So G, let's do it here. G takes 3, maps it to negative 2. G, okay, so let's say that's 6 and that's negative 5, and let's say that's 7 and that's negative 3. So G takes 6, maps it to negative 3, and takes negative 5 and maps it to 7. So that's what I wanted. All right, so let's say A, you want to find G of 6. So again, G of 6 means, if you think of this as x and y, G of 6 means what's the y coordinate when x is 6. So if x is 6, my y coordinate is negative 3. So G of 6 equals negative 3. B, suppose I want to find 4 times G of negative 5. So again, we got to figure out what G of negative 5 is. So G of negative 5 means what's the y coordinate when x is negative 5. So when x is negative 5, my y coordinate is 7. So therefore, this becomes 4 times 7, which is 28. So the answer, you're going to say 4 times G of negative 5 equals 28. Okay? All right, so that was number 4. All right, now let's look at this. So this time we're going to look at some graphs. So I want you to look at this for a moment. So this is going to be this one. All right? So I have this line, and this is my function k of x. And notice it's a function because it passes the vertical line test. But let's suppose I want to find, for this function, let's suppose I want to find a. I'm going to put here a. Let's suppose I want to find k of 0. K of 0. So remember, k of 0 means what's the y value when x is 0. So here's where x is 0. You go up. If you need to use a ruler, you use a ruler, okay? So x is 0 is here. Here's my point. And if you need to label it, you label it. So label if you have to. So k of 0, so when x is 0, my y value is 3. All right, so k of 0 is equal to 3. There's your answer. All right. Let's suppose I want to find in part B, let's do that here. Let's suppose in part B you want to find k of negative 3. K of negative 3. Well, to find k of negative 3, same thing. Here's negative 3. When x is negative 3, here's my point, right? If you think about the coordinates of that point, the coordinates of that point is negative 3, 1. So this is negative 3, 1. So k of negative 3 then would be would be 1. Okay, so that would be the answer there. So k of negative 3 equals 1. C, let's suppose you want to find k of negative 6, minus 2 times k of 4. So k of negative 6 minus 2 times k of 4. All right, the way I would do that is this. So k of negative 6, so remember, what's the y value when x is negative 6? So that's here. So if you think about this, k of negative 6, my coordinate is negative 6 comma negative 1. So my y value is negative 1. So this is negative 1. Minus 2 times, now we got to find k of 4. Well, here's 4 right here. So k of 4, oops, it didn't go, I'm sorry. Let's do k of 3 because k of 4 is not on a grid line. So let's do 3. So k of 3. All right, let's find k of 3. So 2 times k of 3. So k of 3 would be this point here. So that's what? 3, 5. The y value is 5. And so using the order of operations, I'm going to multiply before I subtract. So I get negative 1 minus 10. So a negative 1 and negative 10 is a negative 11. So therefore, you would say k of negative 6 minus 2 times k of 3 equals negative 11. All right, so that's what you do with the graphs. Same idea is the same idea we were doing with the ordered pairs, except now it's in terms of a graph. All right, so that was number 5. All right, let's look at number 6. Number 6, let's suppose we had this graph. So this number 6. All right, let's make this number 6. So we had h of x. So in part A, let's suppose that you want to find h of, let's say, negative 2. H of negative 2. Now remember what that means. That means what is the y value when x is negative 2? So here's where x is negative 2 on the x-axis. So x negative 2, there's your point. Use your rule if you got to. There's the point right here. So label it. Label if you have to. So that point is negative 2, right? And so therefore, when x is negative 2, my y value is negative 2. So the answer is negative 2. Part B, let's suppose in B, you want to find h of negative 6. H of negative 6. Well, the same idea. What's the y value when x is negative 6? So here's where x is negative 6. Use your ruler. So notice when h is negative 6, this point right here represents negative 6, negative 2. Negative 6, negative 2. So my y value is negative 2. So there's your answer. H of negative 6 is equal to negative 2. And that's all you do. That's all you need to do. Okay? So that was number 6. Let's look at number 7. Number 7, you have number 7. Same thing, right? Same idea. So you have this function, you have this graph, and this is my function f of x. Let's suppose you want to find f of 0. F of 0. And that's the only thing I want to find, f of 0. That's all I'm going to find for that one. So remember what that means is what's the y value when x is 0? So remember x is 0 here. So I got to look at that point of the graph. That's just right here. If I label that point, that is 0, 4. So now ask yourself, when x is 0, what's the y value? Well, the y value is 4. All right, so that's number 7. Oh, and by the way, suppose I want to find, let's say B. Suppose in B I want to find f of 7. Negative 7, sorry, negative 7. Well, here's where x is negative 7, right? Right here. Right here. That's x is negative 7. So what's that y value? Well, what's the according to that point? Well, that's negative 7, 0. So what's the y value when x is negative 7? Well, when x is negative 7, the y value is 0. So that's your answer. All right. Number 8. Number 8, let's suppose we had this for number 8. So here's h of x. And so let's suppose in part A, I want to find h of, let's say, negative 2. H of negative 2. So in h of negative 2, here's where negative 2 is. When x is negative 2, my y value is right here. Well, there's my point. My y value is what? It is 5. So if you need to label that point, you label it negative 2, 5, right? Part B, what if I want to find h of negative 4 minus h of negative 6? H of negative 4 minus h of negative 6. Well, again, this means what's the y value when x is negative 4? Well, here's where x is negative 4. Use your ruler if you have to. That point that corresponds to that is up here, right here. So when x is negative 4, my y value is 7. So this is the point negative 4, 7. So that's 7 minus, now we got to find h of negative 6. Well, what's the y value when x is negative 6? So here's negative 6. If I look at the point in the graph, that's just right here. So that right here represents negative 6, 5. Is that correct? So negative 6, 5. So when x is negative 6, my y value is 5. So 7 minus 5 is 2. So h of negative 4 minus h of negative 6 equals 2. And that's all you do. All right. Number 9, real quick, number 9, we have about 2 more problems. Number 9, all right, let's suppose I want to find in part A, this is h of x. So we have this function, passes the vertical line test, right? Let's say h of 3. So what's the y value when x is 3? Well, here's where x is 3. My y value is 0. Part B, let's suppose you want to find 2h of 8 minus 3h of, let's say, negative 3. All right, so 2h of 8 minus 3 times h of negative 3. So let's find h of 8 first. So h of 8. So that's 8, sorry, 8. So h of 8 means what's the y value when x is 8? So when x is 8, my y value is this right here, right? Which is 8. So this is 8, 8. So h of 8 is 8. So that becomes 2 times 8, right? 2 times 8 minus 3 times, now we got to find h of negative 3. So h of negative 3, here's negative 3. So if I look at that point, that's just right here, So my coordinates are negative 3 and my y value is 4, correct? So that means h of negative 3 is equal to 4. So what's the y value when x is negative 3? Well, that's 4. So that goes here. And so I get positive 16, 2 times 8 is 16, minus 3 times 4 is 12, and then 16 minus 12 is 4. So therefore, we can say as the answer, we can say 2h of 8 minus 3h of negative 3 is equal to 4. All right, and then finally, number 10. So we have this, notice that this is a finite set of ordered pairs. We had one like that in a previous lesson. In part A, let me put part A here, and this is my function f. Suppose I want to find f of 8. F of 8. So remember, f of 8 means what's the y value when x is 8? So I got to find x is 8. That's this. The point, there's only one point on the graph, and that's right here, right? It's a function. So I got to find that y value, though. So that y value is negative 2. So f of negative 8 equals negative 2. Part B, what is f of 3? F of 3. Well, again, what's the y value when x is 3? So here's x is 3 right here. Here's my point. The y value is negative 3. Kind of makes sense because if you label it, isn't that 3 negative 3? If you label the point. Part C, suppose I want to find negative 5 times f of negative 7. Suppose I want to find that. Negative 5 times f of negative 7. Well, I got to first of all figure out what f of negative 7 is. So what's the y value when x is negative 7? That's what that means. So here's x is negative 7. Here's the point. Use your ruler. Here's the point. My y value is 6. So if you need to label it, you label it. That's 7, 6. So this right here is 6, right? F of negative 7 is 6. So this becomes negative 5 times 6, because f of negative 7 is 6. So I get negative 30. So the answer you're going to say is negative 5, f of negative 7 equals negative 30. All right? And So that's all I wanted to do with this, was because sometimes you will be given a graph and you will be asked to find function values. You will be given a set of ordered pairs, just like we did here, set of ordered pairs or mappings, and you're asked to find function values. So that is, by the way, that is the end of lesson 3 on part B, which is evaluating functions.